Have you ever wondered how steel nails are made? These tiny pieces of metal hold together furniture, walls, roofs, maybe even the chair you're sitting on right now. But almost nobody thinks about how they're actually created. A nail looks simple, just a sharp piece of steel, but behind every single nail is an incredible manufacturing process. It all begins with massive coils of steel wire and ends with billions of finished nails shipped around the world. Today, we're going inside the factory to discover exactly how steel nails are made. Let's begin. Everything starts with giant coils of steel wire. These are not small rolls of wire from a hardware shop. Some of these steel coils weigh more than a small car. The steel used for nails is carefully selected. It needs to be strong, but still flexible enough to be shaped. One single steel coil can produce hundreds of thousands of nails. That gives you an idea of the massive scale of production. The wire arriving at the factory is usually too thick, so the first major process is called wire drawing. The steel wire is pulled through hardened metal dies, each with a slightly smaller hole. With every pass, the wire becomes thinner and longer. At the same time, the metal actually becomes stronger through a process called work hardening. During this stage, when the wire can move at speeds faster than an Olympic sprinter, by the end of the process, the wire reaches the exact thickness needed for the nail. Now something interesting happens. The wire has become hard and strong, but for certain nails, it needs to become softer again. This process is called annealing. The wire is heated inside a furnace to extremely high temperatures, then cooled slowly. This removes internal stress from the metal, making it more flexible and easier to shape later. Think of it like stretching tired muscles before exercise. Not all nails go through this process. Some heavy-duty nails need to remain extremely hard because the wire has been stored in coils. It naturally wants to stay curved. Before nail production begins, the wire must be perfectly straight. The wire passes through a series of rollers, which gently bend it back and forth. By the end, the wire comes out completely straight. This step is critical. Even a tiny curve could jam the entire machine, and modern nail-making machines move incredibly fast, producing thousands of nails every minute. Now we reach the heart of the operation, the nail-making machine. This is where the wire officially becomes a nail. The straight wire feeds continuously into the machine. In one incredibly fast motion, the machine grips the wire, forms the nail head, cuts the nail to length, and shapes the point. All of this happens in a fraction of a second, and here's the amazing part. The process wastes almost no material. Instead of cutting away metal, the machine compresses and reshapes it using massive force. At the same time, the machine creates the sharp nail tip. Special angled blades cut the end of the wire into a pointed shape. The sharper the point, the easier the nail enters the wood. A properly designed point can even reduce wood splitting. That's why nail design matters more than most people realize. Some nails need extra holding power. For those nails, the shank gets textured. Ring shank nails have circular ridges pressed into them. Spiral nails are twisted like screws. These designs help the nail grip the wood much more tightly. That's why they're commonly used in flooring, roofing, and heavy construction. Some specialty nails can hold up to 40% better than smooth nails. Certain nails need to be hard enough to enter concrete. To achieve that, they go through heat treatment. The nails travel through a high-temperature furnace where the steel structure changes internally. Then they are rapidly cooled in oil or water. This hardens the metal dramatically, but hardened steel can become brittle, so the nails are heated one more time in a process called tempering. This removes brittleness while keeping the strength. Without heat treatment, a masonry nail would simply bend when hammered into concrete. Next comes surface protection, because plain steel rusts. Most nails receive a protective coating. The most common process is galvanizing, where the nails are coated with zinc. Some nails are dipped directly into molten zinc. Others use electricity to apply the coating. These coatings help prevent corrosion, especially in outdoor environments. In coastal regions, where salty air speeds up rusting, coated nails are absolutely essential. After forming and coating, The nails can still have rough edges, so they move into large rotating tumbling drums. Inside the drums, thousands of nails roll against each other, along with abrasive materials. This smooths the surface, removes burrs, and gives the nails a polished appearance. Interestingly, the same tumbling process has been used for centuries in jewelry making. Before the nails leave the factory, they must pass strict quality inspection. Modern factories use high-speed cameras, laser measurements, and manual testing. Machines check for defects like bent nails, incorrect lengths, or damaged heads. Random samples are also tested for hardness and coating thickness, because even tiny defects can become major problems in construction. Every nail must meet precise engineering standards. Finally, the nails are ready for packaging. The finished nails move directly into automated packing systems. Instead of counting nails individually, the machines measure them by weight. Boxes are labeled, sealed, stacked onto pallets, and shipped worldwide. Every year, billions and billions of nails are used across the world, in homes, bridges, furniture, in buildings everywhere. And that's the incredible journey of a steel nail, from a giant coil of raw steel wire to one of the most important tools in human history. Something so small, yet so essential. It's amazing to think that an object costing just a few cents requires metallurgy, precision engineering, high-speed automation, and massive industrial systems to create. If you enjoyed learning how everyday things are made, make sure to subscribe for more deep dives into fascinating manufacturing processes. And tell us in the comments, what should we explore next? Screws, glass, rubber tires? We're taking suggestions. And if you know someone who loves factories, engineering, or construction, share this video with them. Until next time, keep looking closer. Because the most ordinary objects often have the most extraordinary stories.